In this short demo, we're going to take a look at how we can protect SUSE Virtualization VM workloads using Veeam Kasten. Let's have a look. First, I'll navigate to my Harvester cluster, and I'll go ahead and download the kubeconfig file. I'll then import the kubeconfig file and connect to the cluster. Let's connect and check the number of nodes. Next, I'll add the Kasten repository to my local Helm installation and perform the install via Helm. Now I'll go ahead and annotate the storage class so Kasten knows that it supports block mode exports, as well as the volume snapshot class so Kasten knows it can use it for snapshot activities. Let's go ahead and check the status of our Kasten pods. I'll navigate to the Kasten interface by copying the cluster IP and appending the /k10 directory at the end. Here I can see the Kasten dashboard. Returning to the SUSE Virtualization dashboard, let's go ahead and deploy a new VM workload. I'll select Create and change the namespace to Source01 and specify a VM name, as well as CPU and memory allocation. For the first disk, I'll change it to CD-ROM and select an ISO that I'd uploaded earlier, as well as add another disk to which we'll install our operating system and application. I'll go ahead and select the console now that the VM is booted, and I'll perform my operating system installation. We've completed our operating system installation, and we're almost ready to protect our VMs using Kasten. But before doing so, I'm going to go ahead and power off the VM and edit the configuration to remove that installation ISO I had attached during the initial deployment. I'll now power on the VM. Returning to my Kasten dashboard, I'll choose Location under Profiles and confirm that I've configured an S3 compatible object storage repository to which I can back up my VM workloads. I'll now navigate to Policies and create a new policy to protect all objects in the Source01 namespace. I'll choose my backup frequency and specify a snapshot retention schedule. And I'll ensure that I enable backup via snapshot exports to that S3 compatible object storage. Lastly, I'll target all objects in the Source01 namespace. I'll now run my policy. I'll specify a snapshot expiration so the snapshot does not live indefinitely on my cluster storage. Return to the main dashboard, I can monitor the status of my backup job. We can see that our backup job is completed successfully. Next, I'm going to simulate a failure by accidentally deleting a VM. It's worth noting that if a VM is deleted, its associated local snapshots will also be deleted, which is why it's important that we export our backup to an S3 compatible object storage location. Returning to my Kasten dashboard, I'll go ahead and select my Source01 application and choose a restore point that's been exported. You can see here I've got options upon restore. I'll just scroll down and deselect anything that's not associated with my Linux VM that was accidentally deleted. I'll choose Restore and monitor the status of the restore job by navigating to the main dashboard. If I click on my restore action, I can monitor the status and see that the data is being restored from that S3 compatible object storage. Returning to my SUSE dashboard, I can see my VM has been restored in place, and if I open the console, I can see that the OS is booting and the VM is now back and fully functional. So if you have SUSE Virtualization VMs or SUSE Rancher workloads you need to protect against ransomware or disaster, check out the link on screen to get started with Kasten for free today.